Okay, hi everyone. So in this video, we'll learn on the integration and techniques of integration. So what is integration? So integration is the process of finding the definite or indefinite integral. So it is the inverse process of differentiation, or we say the antiderivatives. So the symbol for integration is this. Okay. So if you want to evaluate indefinite integral, so the integration fx dx is equals to the fx plus c. We have the plus c here, okay, which is equivalent to finding a function f such as f prime equals to fx. So means when we differentiate fx here, differentiate, we'll get back to fx. Okay, f prime equals to fx. So we integrate fx, we get the capital Fx. So if we differentiate f prime x, we differentiate fx, if f prime x is equals to fx. So it's actually the inverse or reverse process. So indefinite integral, we have the plus c here. So if it's definite integral, meaning we have limit, the lower limit, the upper limit. So meanings after we integrate, we substitute the value of the upper limit minus when we substitute the value of the lower limit. Okay, so these are some properties of integral. You can refer to textbooks for basic integration formula. So if we want to integrate definite integral, so integrate from a to b is equals to the negative of b to a. We integrate from b to a. So if we have constant k, we can put the k outside of the integral. And if we have addition or subtraction, we can separate the integral. Okay, for example like this, we have 0 to 1 of x squared dx is equals to, if we integrate from 1 negative 1 to 0 of x squared dx. Okay, this is an example. So if another example, a 0 to 1 3x squared dx. So we can put the 3 outside of the integral, so we just integrate x squared dx. Okay, other than that, for example, if we have 3x squared plus exponent x dx, so we want to integrate all this, we can separate it. It becomes 0 to 1 of 3x squared plus integrate 0 to 1 exponent x dx. So meanings we just separate it. So there are properties like this in integral. So let us take a look at this example. First a. So now before we integrate, maybe we can expand it. So negative 4x squared plus 4 sine x dx. Okay. Now it's up to you whether you want to separate. Okay, I want to separate it. Negative 4 integrate x squared plus 4 integrate, sorry, I always forget the dx. Dx is important, okay, because complete the term sine x dx. So now we can integrate. This is indefinite integral because there's no limit on the integral. Okay, negative 4 is constant, just remain the same. So now x power 2 plus 1 x plus 1, 2 plus 1 is 3, divide by the power will be 3 plus 4. If we differentiate sine, if we differentiate cos, we get sine. So integrate sine, we must get So if we differentiate cos x, we'll get negative sin x. So this one is differentiate. So if we want to integrate, okay, sin x, so it must be negative cos x, because there's no negative here, so there must be negative here. So it will be negative cos x plus c. Don't forget the plus c, okay? Because this is indefinite integral, so there must be some constant there. And then we simplify it. It will be 4 over 3 x power 3 minus 4 cos x plus c. That's it for A. For B, okay, again we expand it. We'll get 3x power 3 plus 2x power 3 over x power 4 dx. Okay, so I'll break it to make it clear. So here, before we integrate, we can simplify it one more time. It will be x power 3 plus, okay, x power 3 here, 3 and 4 is x, and x we can cancel it. It's power 3 here, 4, so we're just left with 1 here. So it will be 2x power negative 1, 2 over x, or 2x power negative 1 dx. Okay, don't forget the dx again. Okay, so now we can integrate this. We'll get 3x power 4 over 4 plus 2x negative 1. Sorry, this is 2 over x. Okay, so 3 over 4 x power 4 plus 2 integrate 1 over x is ln x plus c. So that's it. Okay, so that's the answer. It should be 4 here. Yeah, because there's 4 there. Okay, next. Here we have exercise. So I want you to solve this exercise. Okay, next we look at the example on definite integral. Okay, definite integral meaning we need to substitute the limit. So first of all, we need to integrate it. Okay, let us do for A. So it will be x power 4. Okay, before that, let us change into power form first so that we can integrate without mistakes. So now we can just integrate this. So you will get x power 3 will be x power 4 over 4 minus 2 x power negative 2 plus 1 will be x power negative 1 divided by negative 1 plus 4x. The limit is from negative 3 to 4. Remember, always simplify it first in the simplest form before you substitute the limit. Okay, for example here, x power 4 over 4. So here, if what happened to the x here? Yes, have x there. Okay, now we simplify negative, and negative is become positive. 2 over x. X power negative 1 will be over x plus 4x. Okay, 4 negative 3. So we have integrated this. So now we just need to substitute the limit. Remember, the rule is the upper limit minus the lower limit. So we substitute here. 4 power 4. Okay, substitute 4 to each x. 4 power 4 over 4 plus 2 over 4 plus 4 times 4. Minus, okay, negative 3 power 4 over 4 plus 2 over negative 3 plus 4 times negative 3. Okay, and then just use your calculator to get the answer. 161 over 2 minus 91 over 12. So the answer would be 875 over 12. So that's it. Okay, you can give the value in decimal or in fractions, but fraction is the most accurate. Okay, now for B, the function is from 0 to pi, the limit, negative 3x plus 5 sin x minus 2 cos x dx. So now we can just straight away integrate this. So negative 3x will get negative 3x squared over 2. Sin x will get negative cos x. Cos x will get sin x. From 0 to pi. So now you will substitute the limit. Negative 3 pi squared over 2 minus 5 cos pi minus 2 sin pi. Okay, the upper limit minus the lower limit will be, here will be 0 minus 5 cos 0 minus 2 sin 0. Okay, so now make sure your calculator is in degree mode. Okay, if you want to calculate using your calculator, must be in radian mode. So radian mode because it's pi. Okay, so here negative 3 pi squared over 2, cos pi is negative 1, sin pi is 0, cos 0 is 1, sin 0 is 0. So we have plus 5. Okay, and then minus 0 minus here will be negative 5 only. So the answer will be negative 3 pi squared over 2 plus 5. So we can just leave the answer like this, or you can calculate it. Oh, sorry. 5 plus 5 is 10, right? Sorry, my bad. Okay, the rest is correct. Okay. Okay, good. So next, yeah, please try this exercise, okay? Okay, now we'll proceed. We finish on the basics of integration, on how to differentiate between definite and indefinite integral. I repeat again, indefinite integral, we have no limit on the integral and we have plus c. If it is definite integral, we have limits, the upper limit and lower limit. So the answer will be a value. So now, standing of integrations. Some terms of integral cannot be integrated directly. We need some techniques. So there are 3 techniques basically. The first one is the substitution method or substitution rule. The second one is integration by parts, or the same as tabular method. And number 3, we have partial fraction. So we look at the substitution first. So for substitution method, we have u equals to gx. So gx is in f, and we have the derivative of gx or g prime in the integral too. Okay, so there are some pattern that we can use substitution rule, not all. For example, we have 2x sine x squared dx. So g, the f here is sines, okay? F gx here is the sine x squared. So gx is the x squared, okay? F gx here, so gx is the x squared. So g prime x is the 2x. So 2x is here. So this one we can use substitution method, okay? Because the derivative of x squared is in the integral. We have 2x there. So we can use substitution. Okay, I give another example. We have exponent x squared. 2x squared exponent x power 3. So you see, x power 3 is the gx, x squared here is the g prime x. So we can let u equals to x power 3. Okay, the gx. U is the gx. Okay. So in order for you to use substitution method, there must be a term gx that can that equals to u, and the g prime or the derivative of the gx must also be in the integral. Okay, never mind. We will look at the example. Okay, before that, the method. First one, you need to substitute u equals to gx, meaning you need to choose the correct u equals to gx, okay? And then you will differentiate the g prime, okay? Differentiate the gx to get the g prime, and then substitute back in the integral, and we evaluate fu. Okay, for example, if we have just now, where is it? 2x sine x squared, for example. Okay, so the u here is the gx, which is equals to x squared. U equals to x squared. Okay, so this is the first thing. And then number 2, you will differentiate du over dx. Differentiate u respect to dx. So you'll get 2x. And then substitute in the original integral here. So it is 2x. So just substitute u, okay? U equals to 2x, so there will be sine u. So dx is equals to du over 2x. So it will be du over 2x. So you can cancel the 2x here. So you left with sine u du. Okay. So this is number 4. So sine u du, you will integrate. So again integrate sine u. You imagine as you integrate sine x, so you'll get negative cos u plus c. So number 5. So the answer must be in terms of x. So you substitute your g is equals to x squared. So the answer will be negative cos squared plus c. That's it. So this is the step. Okay, let us take a look at the example. Some example. Oh, I show the example for A. Right? So done for A. Next is for B. For x x power 2 exponent 2x power 3 dx. Okay, always choose the correct u. So here the correct u must be, yeah, this one, because x power 3, x power 2. So when you differentiate x power 3, you get x power 2, right? So u equals to 2x power 3. Don't take the exponent because there's no derivative of exponent here. So du over dx is equals to 6x squared. So dx must be equals to du over 6x squared. So the next step is to substitute in the integral. So for x squared, just substitute the u, okay? Exponent u and also the dx will be du divided by 6x squared. So now you can cancel x squared, 4 and 6. So there will be, the new integration will be 2 over 3 exponent u du. So integrate exponent u du, you imagine as you integrate exponent x dx. So it will just be 2 over 3 exponent u plus c. So now you need to substitute back the u. So the answer will be 2 over 3 exponent 2x power 3 plus c. So that's it. Okay, so look at the next example, C and D. Okay, we do for C first. So C here. So which one you want to choose as the U? Okay, the one with the higher power. Okay, so here U will be equals to 3x squared minus 1. Don't take the square root. Okay, so now we differentiate first. Du over dx is equals to 6x. So dx must be equals to du over 6x. Okay, now we can substitute in the original equation. So 2x, so the whole thing here is now become u. So u, square root u, dx is du over 6x. So now you can cancel the x. 2 and 6 will be 1 over 3. So it will be 1 over 3 integrate 1 over u power 1 over 2 du. So how to integrate power? You need to bring it up, right? So it will be 1 over 3 integrate u power negative 1 over 2 du. So now should be no problem. You imagine as x. So it will be u plus 1 will be u 1 over 2 divided by 1 over 2 du. So the answer would be 2 over 3 u power 1 over 2. No more du. So after we integrate, no more du plus c. So now substitute back or replace the u with x. 2 over 3 u is 3x squared minus 1 power 1 over 2 plus c. That's it. Okay, so next for D. Sin 3x cos 3x. So this one you can use substitution too, because sin is or cos is derivative of each other, and we also have 3x. Must be 3x, 3x, 2x, 2x, xx, 4x, 4x. Cannot be 2x here, 3x here. You cannot perform the substitution method. It must be of the same value, 3x, 3x. So now I'll choose u equals to sin sine 3x. So you can choose u equals to cos 3x, it doesn't matter. So du over dx is equals to 3 cos 3x. So dx is equals to du divided by 3 cos 3x. Okay, so now substitute in the original equation. You'll get sine u. Oh, sorry. Okay, there's something wrong here. You cannot choose all. Yes, correct. Sine 3x, again we write again, will be 3 cos 3x. So here is dx is du over 3 cos 3x. So it's correct actually. So your sine x now becomes your u. So cos 3x you maintain, and then dx is equal to du over 3 cos 3x. So cos 3x is cancelled. So you left with 1 over 3 u du. Yes, like this. So now we integrate u. Imagine as you integrate x dx. So you will get u squared over 2 plus c. So now it will be u power 2 over 6, because 3 times 2 is 6 plus c. So replace the u with x, it will be sine 3x squared over 6 plus c. So you can just leave the answer like this. So now can you please do exercise 3?